Hello students, my name is Ronojit Lahiri and I am your physics teacher now. So today we will be discussing about magnetic field due to electricity. Now let's first see how a magnetic field works. So as you can see in the board, so a magnet has two poles, one is north pole and one is south pole. So what happens is there are magnetic field lines between these poles like this. Now this is the magnetic field line configuration of a typical magnet. Now if we now have a conducting wire like this, suppose the current is flowing in this upward direction. Now when the current flows, it is observed that if we place a compass here like this, suppose it's north pole and it's south pole, okay, suppose this is a compass or a magnetic needle, you can say. So now if we place it near to this wire where I current is flowing, we can see this, due to this current, this compass is being deflected to either of the directions. Depends on the flow of the current, depends on the direction of the electric current flow. Now here, if we have let's have a wire like this, okay, and suppose I have a sheet of cardboard through which I am passing this wire, okay, and suppose first the current is, okay, so let me draw a circuit here for you. This is our battery and suppose this is a switch, and we will we will put some iron fillings like this in the cardboard, okay. So now the circuit is closed. If we connect the circuit like this, as you can see, if we connect the circuit through through opening through closing the switch, we can observe that these iron fillings that were here before, in a scattered way, it will be aligned, forming some concentric circles like this. So now from this phenomenon, we can, we have discussed a previous phenomenon where the magnetic needle was being deflected, and this phenomenon also, it shows that when current is passed through a wire, then it creates a magnetic field. And how the magnetic field looks? The magnetic field looks like concentric circles, okay. Now which will be the, because as you know that magnetic field has is a vector quantity, so it will have its direction, okay. So now how can we actually get the direction of the magnetic field? So suppose this is my wire here. Now I'm placing the thumb on the direction of the, suppose this is the direction where the current is flowing. Now let me put my thumb here, okay, and my fingers are rounding like this way. So as you can see, thumb is right this way and my fingers are pointing towards like this. It's like a it's like a circular it's like a circular direction, okay. Now if this is the direction where the current is flowing, the magnetic field it will produce will have a direction like this. You know, it will be either clockwise or anti-clockwise. If you see like this, if this is the current, this is the direction of the current. So you could see, from this from this picture, that the magnetic field here, okay, it's like, so the current is moving away from the board like this way. Okay, so my fingers are in anti-clockwise position, my rest of the fingers, leaving the thumb. So this will be the direction of the magnetic field. And if we do it like this, okay, so we will have a clockwise direction of the magnetic field. So this, like what I have taught you just now, this is a law. Okay, it is called as, it's not a law actually, basically it's a rule to predict the direction of the magnetic field. It's called right hand thumb rule. Thank you for your time.